Hey, what's up? It's Jake, and that pretty much covers most of, or at least a good portion of the data structures that we're going to use. I keep saying I recommend you read the documentation. It's not a cop out. Like everybody should read that. Like I read it. Everybody should read it all the time. Um, because there's other data types as well, and it's definitely worth it. Um, Everything you're going to write is going to be about handling data, so make sure that, if nothing else, before you really move on, that you have like a rock solid understanding of data types and how they can be used and manipulated, and what kind of objects are what type and what you can do with each type and how they're structured and all that stuff. So I thought a fun way to end this one is just to kind of go over a couple little funny little things with Python as we've been doing some stuff. So you may remember that we said um, that if you create an object, it creates a unique ID every time it's created, right? So let's take a million. So 1, 1, 2, 3, 1, 2, 3, or let's use our underscore 1, 2, 3 just for readability. So A is 1 million. Okay. B is also going to equal 1 million. Okay. So the ID of A is this. The ID of B is this. And we see that the ID of A should be exactly equal to the ID of B, which is false, or that it's not going to be, and it's false. And that's a good thing because A should have its own ID and B should have its own ID. But what if I use a simpler number? What if I said A equals 5 and B equals 5, and then I got the ID of A and equals to ID of B? And you'll see that it's true. So how is it that an object can have a new ID when it's created, and yet these two objects have identical IDs? Well, let's just double check. What's the ID of A? Ends in 8304. An ID of B um, also ends in 8304. Well, Python actually uses performance caching for the numbers -5 to 256. And it just does this, like I said, it's performance things so that it can go much faster. So if there's two objects mapped to the same value, you can actually, it will cache that and create its own map and provide a single point so that no matter however many times A and B are called, it's actually just calling the same point, and that makes it much, much, much faster because when your program runs in memory, it's going to have that one address registered and just be going to the same place every single time, which makes it much faster. I mean, you can see the limit here if I do with 256. So if I say A is 256, B is 256, are they equal? It'll say yes. But if I say that A is 257 and B is 257, you can see the limitation here when it says that it's false. So, and the same thing holds true if you check the -5 and -6. -6 would not be true. -5 would cache for performance and it would be true. So that's just one little weird thing. But just know that it's for performance. It's intentional. It's built into how Python caches stuff. So um, the second thing I wanted to talk about was about um, choosing data structures. So we've got tons of different built-in data structure types. If you're not super experienced, choosing one can be kind of tricky. Like, should I use a list? Should I use a tuple? Should I use a dictionary? Should I, like, what do you do? Um, when it comes to collections, it's even trickier, right? So if you have many dictionaries to store and each represents like a different customer, for example, with each customer dictionary, you have an ID, um, some sort of code, right? And it's unique. And so what kind of collection would you put that in? I mean, unless you know more about the customer, it's kind of hard to answer, right? You know, what kind of access do you need? What kind of data operations are you going to perform? You'd need to answer a couple questions to know what the best way to store it is. So, especially things like, is this something that needs to be modified down the road, like we saw with the optometrist? Um, so, and what is it going to be used for most frequently? These are kinds of the things that you might want to ask. So, if you can answer those questions, you'll know what to choose. The collection will really just depend on what you're going to use it for. and everything has different unique identifiers, then a dictionary will work for you. If they don't have unique identifiers, then maybe something else needs to be chosen. So this is where you need to decide whether mutability or immutability of your object values are important to you. So that's all I'm going to say about that. And then the third thing I wanted to talk about was indexing and slicing. So we did a little bit of that, and we did it to different kinds of sequences, right? Tuples, lists, strings, and so on. It can use for assignment, as we saw, right? And you almost never see this used, but it's good to know that you can. So you can slice a dictionary. Um, I don't know that you'd want to do that. Uh, so there's a different way of doing things that might be more preferable. So again, it just goes back to use case stuff, right? Um, but there's one thing, I guess, with indexing I didn't talk about, and I'll just show this. Uh, and that's that if you create a list in a range like this, and then, oops, not A, S, A, yeah, there we go. And I just created a range of 10, so numbers 0 through 9, right? If I take the length of A, it's 10, right? And then if I said A, and then I want to make a list as the length of A minus 1 here. This is a position of the last one of the length minus 1, which would be 9, which makes sense. But one thing we didn't talk about was negative positioning, which is like this. So -1 is the last number. -2 is the second to last number. -3 is the third. So sometimes it's easier to count from the end back than it is from the front forward. And so as far as indexings go, we want to look at reverse indexing or negative indexing, where you start at the end being -1 and going back the other direction. So in this case, like if A of -3 is 7, but also A 8, A 8, I'm sorry, A7 is 7, then you could say A7 equals A -3, and they're the same number. So depending on, like I said, the length sometimes is important, or you need to get numbers from the end. If you're dealing with currency, you need the cents or something like that. Um, you can go either direction, and it's the same thing. So, yeah. So, and it's just it's good to know the regular left to right way would be called positive indexing, and then using negative numbers is negative indexing. Um, If you try to index things greater than 9 or smaller than -10, you'll get an index error outside of here because the index doesn't exist. So just make sure that you get the length first, and you'll know kind of what your range is that you need to be working with. So then the last thing is about names. So you notice in order to keep all the examples as short as possible, I've been naming things like A and S and stuff like that. That's perfectly fine if you're debugging the console or showing like a simple calculation or something like that, but it's actually bad practice in professional coding. So, or any type of coding. So I'm presenting the code in a more compact way to make it easy and fast. Um, in a real environment, you want to choose names for your data that are meaningful, right? So they should reflect something about the data so you can infer things. If you have a collection of customer objects, customers is a perfectly good name for it. Customer list, customer tuple, customer collection. I mean, if you think about it, if you type the name collection to a data type, it's probably not so great, right? But if you have different nouns that you can use that make things make a little bit more sense, then other people that read your code will be able to understand what that variable is for, or what that collection or library, or dictionary, or whatever is for, and have kind of better just implicit knowledge of what they could find in a sequence, or what kind of values they might be able to expect, or even how the data is used in other places. So that is it. I hope that makes sense. And if you have any questions, let me know. But if not, then we'll just move on to the next section.